So we've talked about central angles and minor arcs and major arcs. Now we're going to take a look at congruent angles and congruent arcs. If we have two angles that are adjacent, remember adjacent means they share a vertex but they don't overlap. So angle ABC and angle CBD are adjacent angles. We also have adjacent arcs, angle AC and CD, because they're bounded by these two angles. I'm going to tell you that each of these two is 45 degrees. So you can tell me that they are congruent. We can have congruent arcs just like we can have congruent angles. So if AC is 45 and CD is 45, what is the measure of ACD? You're right, I can just add them together and it's 90. Just like adding angles together gives me the greater whole, the two parts equal the whole. Same is true in arcs as long as they are not overlapping. And that's what postulate 18 tells us, that if we have two adjacent arcs, we can add those measures together to find the entire arc. All right, a couple of random theorems that are going to make perfect sense. Two minor arcs are congruent if their central angles are congruent. So as long as ABC and CBD equal the same amount, so is the length that's opposite it. And then two minor arcs are congruent if their chords are congruent. So the chord of a minor arc would be the line segment that connects the two vertices on the arc. And if these two measures are the same, then exactly these two angles have been opened to the same width. So that means the arc is going to be the same. So we have another theorem that tells us if a diameter is perpendicular to a chord, then it bisects the chord and the arc. All right, so perpendicular means what? A right angle. You're correct. So if I were to take this and complete a triangle by drawing radiuses, we would know that we have these two sides congruent, and it tells us that if a diameter is perpendicular, then it bisects the chord and the arc. We also know that we've got this leg, this part of both triangles congruent, so we have hypotenuse leg to prove that these two triangles are congruent. When they're congruent, we know that the sides of the chord are congruent by CP/CTC. So that's how we know that this theorem applies. If it's perpendicular, it bisects the chord. Also, it's going to bisect the arc because now it's made two central angles that are congruent. So it's going to give us congruent arcs.